Hello everyone, how's everyone doing? This is Cavell speaking, and today I'm going to be talking about how to divide polynomials by polynomials. Okay, so to really help us understand how to divide polynomials by polynomials through long division, we need to think back to how we do long division in the traditional sense with just numbers. So you have a problem, 1079 divided by 43, right? So let's talk about what each of the parts of this expression is, or this equation is. 1079 is called the dividend, D-V-I-D-E-N, dividend, sorry, dividend, right? And then the 43, the thing it's being divided by, is called the divisor, right? And whatever answer we get is called the quotient, right? So just like the sum is the answer to an addition problem, difference is the answer to a subtraction problem, and product is the answer to a multiplication problem, quotient is the answer to a division problem. Okay, so that's just the names of all the parts of this equation, right? So let's get into dividing 1079 by 43. Okay, so first thing we do in long division is we write this bar, right? And then we put 1079 inside, right? So we put the dividend inside and we put the divisor on the outside. So if you recall, right, you ask yourself, does 43 go into 1? No. Does 43 go into 10? No. Does 43 go into 107? Yes. 43 goes into 107 2 times. So you subtract 86, right? So you subtract, this is 1. Remember, you got to borrow, right? You get 21, right? And then we have to pull down the 9, right? And then ask yourself, how many times does 43 go into 219? Well, let's see. If I do 5 times 43, right, that would be 215. So that's perfect. So 5, right? We have 215. And then my remainder is 4, right? So it's 25, remainder 4, right? And if you think about it, right, you can either write 25 remainder 4, right? Or if I just move this to the left here, or you would write 25 and 4 over 43, right? So how do we check this? Well, it's simple, right? We can obviously multiply this 43 back to either of our answers and see if we get back 1079, right? So let's do exactly that. So 43 times 25, right? This is 15, right? 5 times 4 is 20, 21. Cross this out. 2 times 3 is 6. Remember, put a 0. 3 times 4 is 8. We have to add these guys together. And we get 1075, right? But then we need to multiply, right? So what we're technically doing is 43 times 25 and 4 over 43, right? So this is technically what? 25 plus 4 over 43, right? So when we multiply all this by 43, right, we need to distribute, right? So this guy over here becomes what? 1075. And then 43 times 4 over 43 is just 4. So it's basically 1075 plus 4, right? And this is obviously 1079. Okay. And obviously the same thing works for the very first thing we did, right? 43 times 25 is 1075. Remainder 4 means we add 4 and we get the same thing. Okay. So let's go through each of the steps, right? We have the dividend divided by this divisor 43. That's how many times this goes into this, right? We subtract whatever difference we get, we pull down the number, ask ourselves how many times it goes in. And then once this remainder is a number lower than 43, we pretty much stop, right? unless we want to get you know, decimal answers, but for now we don't have to worry about that. So I'm going to delete all this. And now we're going to be doing polynomial long division. Okay, and it's going to work very similar. Okay, so if you remember, right, division can be represented by what? By a fraction bar, right? So let me have this equation, or this division problem, and it says x squared plus 8x, right, plus 19, and this is all being divided by x plus 5. Okay, so what's going on here? X squared plus 8x plus 19 is divided by x plus 5, right? So what's the dividend? Well, it's x squared plus 8x plus 19, and the divisor is x plus 5. So let's do this again, right? So once again, we write this out as long division. So leave a little bit of room up top for yourself, and leave a lot of room on the bottom so you have room to work with. So inside is x squared plus 8x plus 19, right? Oh, forgot about the plus, right? And then now we need to have x plus 5 on the outside, which is the divisor, okay? So same thing, right? How many of these goes into the first thing, right? Well, we ask ourselves, okay, x plus 5 into x squared. So I can multiply it by x, right? So when I multiply this by x, what do we get? I get x squared, right, plus 5x, okay? So now we just subtract, right? Just like we would in the original problem we saw, right? We multiply by some number, get it close to this guy, and then subtract, right? So then we have x squared minus x squared is 0. 8x minus 5x is 3x, right? 19 minus 0 is just 19, so I do plus 19. And then now we ask ourselves, okay, how do I get x plus 5 to look like 3x, right? Well, I multiply by 3, right? So I would add plus 3. So 3 times x plus 5 is 3x plus 15, right? And then remember, we're subtracting for all these, so let me just make sure you guys see that. So 3x minus 3x is 0. 19 minus 15 is 4, okay? So what's my answer? My answer is x plus 3 plus 4, so this is the remainder part, x plus 5, okay? So what's going on here? This is very similar to how we did the long division, right? We got a remainder, right? And we put it over its divisor, right? And then within each steps, we ask ourselves, how many times does the divisor go into the first term, or whatever number this is, right? And we keep going forward, just like you saw previously with the equation with just numbers, right? So obviously in math, it's always a good idea to check, right? So my answer is x plus 3 plus 4 times x plus 5, right? And then by theory, right, if I multiply this by x plus 5, right, I should be getting back this top part, right? So let's see. Let's delete this, let's delete this, delete this, delete this. Right, so let's see what this becomes, right? So let's do x plus 3 times x plus 5, right? In order to do this, if you saw the previous video, right, we need to use FOIL, right? So this is x squared, outer plus 5x, inner is plus 3x, and then outer, right? 3 times 5 is plus 15. And I get x squared, right, plus 8x plus 15, right? And that was my remainder. Remainder was 4, right? So I have to multiply these two guys with this guy. And I get 4 over x plus 5 times x plus 5 is just plus 4, right? And I get x squared plus 8x plus 19, right? And this does match the numerator of the original equation. Okay. So what did we learn here? We learned that, when it comes to long division, we treat it like we would with a regular number. See how many times divisor goes in dividend, subtract, bring down number, rinse, repeat. At the end, if we get a remainder, whether or not you get a remainder, you put it over its divisor, right? So the divisor in this case was x plus 5, so I put 4 over x plus 5, right? And we checked, right, by multiplying the quotient, right? The quotient, this would be our quotient here. Let me circle this in blue. So our quotient would be this guy, right? Our quotient multiplied by our divisor, and orange multiplied by a divisor, right, gets our dividend. Okay. Let's do another example just to really, let's do a few more examples just to really understand what's going on here. So the first question I have is 8x squared, right, minus 12x plus 4. It's all being divided by, so let me make this a little bit neater, divided by 4. So the easiest way, right, you can see that every term in this polynomial can be divided by 4. So you just get 8 divided by 4 is 2x squared. All right. Negative 12x divided by 4 is negative 3x. Right. 4 divided by 4 is just plus 1. Right. So that'd be the easy way. So now just to work on our long division or polynomial long division, right, we would do what we did before. Write out the dividend inside. 8x squared minus 12x plus 4, all being divided by 4, right? So just like in regular long division, you ask yourself, okay, how many times 4 go into 8x squared? Simple, it's just 2x squared, right? So this is 8x squared, right? Remember, this is subtracting, right? So now you just get negative 12x plus 4, right? How do I get 4 to look like negative 12x? Well, you multiply it by negative 3x, and you get negative 12x, right? Remember, this is negative, right? We're subtracting it. So this goes away. Just left with 4. How many times 4 go into 4? Well, that's just 1, right? I subtract 4, and I get 0, right? So as you can see, we do get the same quotient throughout, right? And then you can also simply see that if I multiply the quotient by 4, I would get back 8x squared minus 12x plus 4. Okay. Let's do another problem. Okay. The next one we have is y squared plus 12y plus 36, all being divided by y plus 6. Okay. So one thing I do want to say is that obviously if you can factor, that'd be the best method and it would save you the most time. But long division is one of those methods that will work regardless, right? It might take more time, but it's rare in math to have something that always works. So just for the sake of practicing long division, right, we'll be doing long division with this. So what's our dividend, right? It's y squared plus 12y plus 36, right? This is all being divided by y plus 6, right? Same thing. How many times does y plus 6 go into y squared? Well, I just multiply by y. Now it's y squared, right? Plus 6y. Remember, this being subtracted. This goes away. 12 minus 6y is 6y. The 36 just comes down for the ride. Y times what is 6y? Well, multiply by 6, so I get y plus 6, right? So 6 times y plus 6 is 6y plus 36, right? I remember this is all being subtracted. Hence why I put parentheses and then I subtract, right? So 6y's cancel out, 36 cancels out, so I get a remainder of 0. So that means y plus 6, right, is my quotient, right? And how do we check? Well, it means that my quotient is equal to my divisor multiplied by quotient, right? So my dividend, y squared plus 12y plus 36 is equal to my quotient multiplied by divisor. Okay, so y plus 6 times y plus 6 should equal to y squared plus 12y plus 36. Oh, sorry, 36. And we can check that by using FOIL again. So you get y squared, right, plus 6y. That's outer, right? Inner plus 6y, and then last 6 times 6 is positive 36. That is obviously equal to y squared plus 12y plus 36. Okay, so we do get back the right answer. All right, let's do a few more just to really get the gist of these questions. All right, next one we're gonna do is, let's see, I have h squared minus 11k plus 30. Okay, this is all being divided by k minus 3. Okay, oh sorry, that's a k squared, by the way, not h squared. Once again, let's rewrite it in long division format. K squared minus 11k plus 30 is my dividend. My divisor is k minus 3. Right? How many times does k go into k squared? Well, k times. So I do minus, right? K squared minus 3k. Crosses out. Negative 11k plus 3k, right, is negative 8k. Plus 30. K goes into negative 8k. Negative 8 times. Minus, right, 8k, right, plus 24. Remember, this is all being subtracted, right? The 8k's cancel out. 30 minus 24 is 6, right? So I get k minus 8 with a remainder of 6, and obviously we can add that as 6 over k minus 3, right? And remember, we can always check out work, right? So let's do exactly that. Let's check. All right. So my dividend should equal to my quotient, right, multiplied by my divisor. So I should have k minus 3 times k minus 8 plus, right, 6 times k minus 3. Right. So we take each of these guys and multiply it by each of these guys, right? So k minus 3 times k is k squared minus 3k. K minus 3 times minus 8 is negative 8k plus 24. K minus 3 times 6 over k minus 3 is just plus 6, right? Let's simplify this. K squared, cross it out when you're done. Negative 3k and negative 8k is a negative 11k. Cross them out as you simplify. And 24 plus 6 is equal to 30. Okay. So as you can see, right, the quotient multiplied by the divisor gives me back the dividend. Right? And just to really show you why that works is because let's just say 9 divided by, hold on, 9 divided by 3 is 3, so this is my dividend, divisor, quotient multiplied by divisor should equal to dividend, which is true, right? 3 times 3 is equal to 9. Okay. Let's see. Okay. Let's do a problem. a quick problem. So it says here we're given a rectangle. Okay. Given this rectangle here. Okay. Let's make dotted lines. Okay, this is dotted lines. So it says the measures of the length and width of a rectangle are 3x plus 4 and 2x plus 2. So 3x plus 4. Okay. 2x plus 2. Okay. And then it says find the area of each of the 4 regions into which the rectangle is partitioned. Then add 3 values to find the area of the rectangle. Okay. So find the area of each of the 4 regions, right? So this region's area, right, is this box, right? That can be represented by 2x times 3x, right? So this will be 6x squared. This rectangle at the bottom here, right, can be represented by 2 times 3x, right? So this would be 6x. And then for this box right here, right, we have 2x times 4, right, which is 8x. And for this last one, right, we have 4 times 2, which is 8, right? So the area of this entire box, right, is 6x squared plus 6x plus 8x is 14x plus 8, okay? But for each of the box, for each of the regions that's partitioned within this rectangle, these are the corresponding areas, okay? And part B says, show that the area of the rectangle is found by multiplying 3x plus 4 times 2x plus 2. Well, it's true, right? So what's the area of a rectangle? Length times width, right? Area is equal to length times width, right? So this is length. Oh, sorry, that's width. It's my length. I should be technically getting this when I multiply 3x plus 4 times 2x plus 2, right? Let's see. Once again, FOIL, 3x and 2x makes 6x squared. 3x and 2 makes 6x. 4 and 2x makes 8x. 4 and 2 makes 8, right? Combine like terms, 6x squared plus 14x plus 8, okay? This is all the same, all right? Same thing as this, okay? And then for part C, it says express the perimeter of the rectangle as a binomial, okay? So let's look at the perimeter, right? Perimeter is equal to 2L plus 2W. In other words, add up the lengths, or 2 times the lengths, right? And 2 times width and add them together, right? So let's see that. So we have 2x squared plus 2 times 2, right? 2x squared, oh sorry, just 2x times 2, right? This is my width, right? What's my length? 2, and then my length is 3x plus 4. Right, since it's a rectangle, these sides are parallel, right? They're opposite of each other, so therefore they are equal, right? So the dimensions are as such, right? This is my length, right? So here we get 4x plus 4 plus 6x, right? 2 times 3x is 6x. 2 times 4 is 8, right? My perimeter is 10x plus 12. So this is equal to my perimeter, all right? That's all today for dividing polynomials. Thank you for watching. Bye-bye.